Good morning to all. I am Subramaniam from Automobile Department, working as Assistant Professor in Automobile Department in SNS College of Technology. In the last session, we have seen about the CNG system, CNG fuel system, so CNG fuel component system. Now, in this session, we are going to see about the engine design for the CNG vehicles. Here, the engine design for the vehicles running on compressed natural gas, that is CNG, differs significantly from those designed for traditional fuels like gasoline or diesel. These differences stem from the unique properties of CNG as a fuel, which require specific adaptations to ensure optimal performance, efficiency, and durability. First point, the cylinder head and valve modifications. One of the key differences in the CNG engine design is the need for modification to the cylinder head and valves. CNG burns at higher temperature than the gasoline, which can lead to increased wear on the engine valves and seats. To address this, CNG engines typically feature hardened valve seats and valves made from the more heat resistant materials. These modifications help prevent premature wear and ensure the engine can withstand the higher combustion temperature associated with the CNG. And next, we see the compression ratio adjustments. CNG is one of the compressed natural gas engines often have higher compression ratio compared to gasoline engines. This is because CNG has a higher octane rating, which allows it to withstand high pressure without detonating prematurely. Increasing the compression ratio in a CNG engine improves the thermal efficiency and power. Making the most of the CNG combustion properties. In contrast, gasoline engines with the lower compression ratio not optimized to fully exploit the benefits of CNG. Next comes the fuel injection system. The fuel injection system in CNG differs from those of the gasolines or diesel engines due to the different physical state and combustion characteristics of CNG. In CNG engines, fuel injectors are designed to handle the gaseous state of the natural gas, requiring precise control to deliver the correct number of the fuel to the combustion chamber. This is typically managed by the sophisticated electronic control unit (ECU) that adjusts the fuel injection timing and amount based on real-time engine conditions. Next comes the ignition system. CNG engines require a stronger ignition system to ensure the reliable ignition of the air-fuel mixture. CNG has a higher ignition temperature compared to gasoline, which means that spark plugs and the ignition coils must generate a stronger spark to ignite the mixture. As a result, CNG engines often use specialized spark plugs with the higher heat resistance and better conductivity, ensuring consistent ignition under all operating conditions. Lubricating and cooling. CNG may require different lubrications and cooling strategies due to the clean burning nature of CNG. Since the CNG produces fewer carbon deposits and contaminants, the engine oil remains cleaner for longer periods. However, the higher combustion temperature necessitates more efficient cooling systems to prevent overheating and ensure long-term engine durability. Some CNG engines are equipped with improved cooling systems to use the oil specifically formulated to handle higher operating temperature. Finally comes the exhaust system. The exhaust system of the CNG engines is generally simpler than in gasoline or diesel engines due to the cleaner combustion of the natural gas. CNG produces fewer byproducts like soot and unburned hydrocarbons, which reduce the need for the complex of after heat treatment like particular particulate filters or the catalytic converters. So, in this session we have seen about the CNG machines. In this session we have seen about the CNG engine design of the CNG vehicles. Thank you for watching it.